We are now going to review the metric system. Metric system is the measurement system for the international community and also for the science community. There's some variations within the metric system. So the preferred variation is the SI system, the Système International. And the SI system is just a subset of the metric system, but it's a unified subset that allows us to convert between properties. So some units for the metric system. These are called base units. There are also derived units derived from the base units. So for distance, length, the unit is meter. The symbol is lowercase m. And this is the SI unit for distance or length. For mass, the base unit would be the gram. The gram is, its symbol is lowercase g. It's not the SI unit. The SI unit would be the kilogram. So we're going to cover prefixes in a moment. We adjust size of the metric units by using prefixes. Kilo means 1,000, so kilogram is 1,000 grams. Kilos symbol is K, gram is G, so kilogram is kg. This is the SI unit, so SI unit for mass is a kilogram. The atomic mass unit, abbreviated U, or in the American system, more often AMU, is also considered to be a metric unit, but it's definitely not a SI unit. For time, the metric unit is the second. This is abbreviated lowercase s, and this is the SI unit. So we don't use minutes, hours, days, or anything like that, just seconds. Temperature, there are two metrics, temperature scales, Celsius and Kelvin. Celsius unit is degree C, because it's degree Celsius. Kelvin, its unit is K, and it's only Kelvin, not degrees. Both these units have the same temperature size, so if we increase the temperature 5 degrees Celsius, we have increased the temperature 5 Kelvin. The difference is the zeros. We know 0 for Celsius would be the freezing point of water. 0 for Kelvin is the lowest temperature possible anywhere in the universe. Kelvin is the absolute temperature scale, and it is the SI temperature scale. For amount of substance, the unit is the mole. We will be defining this later on. It's spelled M-O-L-E, and it's abbreviated M-O-L. This is a SI unit of amount of substance. And for electrical current, the unit would be the ampere, abbreviated A, capital A, and it's the SI unit for electrical current. From the base units, we have derived units. For heat or energy, or heat, we have two metric units, the joule and the calorie. Calorie, which is abbreviated CAL, lowercase CAL. This is not the same as a food calorie. Calorie was designed for chemists. The other unit is the joule, abbreviated capital J. The joule was designed for physicists, but the joule was incorporated into other units that became part of the SI unit, so the joule became the SI unit. Calorie is not SI unit. And here we can see after the capital J under the symbol, we see in brackets m squared kg S minus 2. That's meters squared, kilograms per second squared. These are the base units. This is showing how the joule is derived from the base units. It also shows how we can convert between energy, mass in kilograms, energy in joules, mass in kilograms, distance in meters, velocity in meters per second, acceleration in terms of meters per second squared. So the SI units allow us to convert between different properties. For volume, we as chemists use liters primarily. This is abbreviated capital L, but this is not the SI unit. SI unit would be the cubic meter. For density, we tend to use grams per milliliter or grams per cubic centimeter. The SI unit would be kilogram per cubic meter. For concentration, we like to use molarity, which is moles of solute per liters of solution. The SI unit would be moles of solute per cubic meter of solution. For gas pressure, we will use a variety of things. Our base pressure, our most commonly used pressure, would be the atmosphere. And that is abbreviated as ATM. The SI unit would be the Pascal. And for the Pascal, a Pascal is a Newton per meter squared. So that's the N per meter squared. That's Newton per meter squared. So Newton is force. And down to the base units would be kilogram per meter per second squared. For specific heat, which is a measure of how objects change temperature as heat is added, specific heat, the SI unit is joules per kilogram Kelvin. So joules per kilogram Kelvin. So we adjust our metric units by using prefixes. Now if we're using the SI system, which means that we're converting between properties, we're using the SI system, we stick with the SI unit. If we're not converting between properties and we don't have to stick with the SI system, we can use any of the prefixes that seems appropriate to us. So the top 4 prefixes are to make things larger. The first one will be kilo with symbol lowercase k, and this is for 1,000. So if we stick it in front of something like a meter, a kilometer, kilometer, that would be 1,000 meters. Above that would be mega, symbols capital M. This means a million, 10 to the 6th. So in the prefix system, we generally are doing multiples of 1,000, although there are a couple that step in between that. So mega means a million. Giga, symbol uppercase G, means 1 billion, 10 to the 9th. Tera, symbol uppercase T, means 1 trillion, 10 to the 12th. And that's all I'm asking for us to know. The prefix system goes much larger than this. but for going up in large size, that's all I'm asking for. Going down to small size, we have a couple additional prefixes that are not multiples of 1,000. So 1/10 is deci with the symbol of lowercase d. It's not used all that commonly. 100th is centi, symbol is lowercase c, and this is a pretty common one. And then from there we're back onto the multiples of 1,000. So 1,000th is milli, symbol lowercase m. And then 1/billionth would be micro, and its symbol is the Greek letter mu. One billionth is nano, symbols lowercase n. And when news articles talk about nanotechnology, they're just using this term loosely to mean something very, very small. One trillionth would be pico, symbol lowercase p. So it's 10 to the minus 12, 1 trillionth. So all these symbols, they never stand alone. These always are in front of a symbol of a property. So in front of meters or seconds or grams or something like that.